Okay, so today's lecture will be on perception, and this is a topic which I find quite interesting because, well, it's a phenomenon. We all have an idea, vague idea of what perception is, but on top of that, we also have high order cognitive states, such as being aware of the stimuli that we receive from our surroundings, and to some extent also that we become consciously aware of our surroundings and ourselves. So it's sort of a multi-stage phenomenon where some of the basic characteristics of some of our higher order functions, they rest on the fact that we perceive something, that we receive some sensory information from the external world, and that we are then able to use them in a sensible way. And the brain has some mechanisms, so it has properties where certain areas of the brain have high degree of specialization. So certain areas of the brain, they are able to process very specific stimuli. On the other hand, we also have a lot of processes which are distributed between a lot of systems in the brain and require integration of several different kinds of information. And I hope that with this lecture, I'll not just show you some simple ways of perception, but also give you some examples on how a lot of information from different sensory modalities can be integrated into sort of a higher order perception. So for a couple of lectures ago, we looked at the primary visual cortex, so Broadman area 17 in the occipital lobe. And we saw how the stimuli from the left hemisphere and from the left hemifield and the right hemifield are projected to the opposite hemispheres of the primary visual cortex. And we also saw that there is this retinotopic distribution of the way that the primary visual cortex is organized. So we see that parts that are located near the central, the fovea, well, they are located here in the most posterior part of the visual cortex, and then if we go further out in the periphery, we move further anterior in the primary visual cortex. Also, we have this organization with the parts of the visual field that are on the upper part will be projected down to the lower part of the primary visual cortex. So today we will go a bit further on this this distinction with the different parts of the visual field. And if you look closer on the primary or on the visual cortex, you will actually notice that there are a lot of different visual fields in the visual cortex. So back here we have the primary visual cortex V1, and then going further up we have the secondary visual cortex V2, V3, V3A, V3B, etc., etc., etc. And you can make all these subdivisions of the primary or of the visual cortex. And what you will see is that this idea of the retinotopic organization of the visual field is actually something that also is reflected in not only the primary visual cortex, but also in the higher visual areas. So you'll see that parts that are up, for instance, in the visual field, they are marked here with a plus and minus later for the lower part of the visual field, and you also have the fovea in the center. And you will actually see that each of these visual areas, they process some type of information, and they also, to a large extent, also have this visual or this retinotopic organization. When you go up to the very specialized regions, for instance, the motion sensitive areas, MT, and you still have some degree of this retinotopic organization, but it's also beginning to be more diffuse what these different regions do, and you will see that actually some of the regions, they process the same features. Yeah.
Can you repeat the part about the plus and the minus?
So the plus and the minus means that within each of these visual areas, the upper part of the visual, the hemifields, so what you see on top, is represented with the plus, and the lower part with the minus, and then you have the central part of the visual field, the fovea, is the circle. So you will actually see that within each of these visual areas, you have this retinotopic organization preserved so that something that's presented in the center is presented in one part, and neighboring parts of the visual field will also be neighboring in their representation in the respective visual area. And this is preserved up even into very highly specialized visual areas. So for instance, the motion sensitive area MT. It's not in all of them, but it's in a lot of these areas that you have this retinotopic organization.